Hello everyone, how are you? I hope you all are doing fine. By the way, welcome to my YouTube channel Cbse in Nutshell. And if you are just new to this channel, do subscribe to my channel. And if you just like my way of teaching, just hit the like button. Okay. By the way, after so many days, I'm making video. And if you ask me why sir you're not making videos from last couple of days, so consider that I was giving you actually what some summer vacations. Now all the vacations are actually over, and from now today onwards we're going to start the classes, or we're just going to do the classes as always we actually are doing, right? So from today onwards we're going to start in regular manner, and from today's video and from our today's video we're going to start where we actually ended in our last class, right? So in today's class we're going to discuss some numerical problems regarding the lesson work and energy, okay? And all those numerical problems are going to be from your exercise part, only the numerical problems, right? So we'll not do any further delay, and now let's start the class. Okay, this is our first problem, right? This problem is actually saying that certain force acting on a 20 kg mass, that is the mass is actually given, right? Mass is actually given, and changes its velocity from 5 meter per second to 2 meter per second. Now what you have to do, or what you have to calculate, you have to calculate the work done by the force, right? We know that there is one formula of calculating the work. That formula is nothing but what? W equal to what? Force into displacement, right? Here force is not given and displacement is not given. What is given? Velocity is change and the mass is given. So we have to find out a formula through which we can actually calculate the what? Work done. So there is one formula. We should know that. That is work done is equal to, can you tell me that? Nothing but what? Change in kinetic, right? Energy. Okay, change in kinetic energy. This is the formula that we are actually going to use. Okay, so we will represent the work done by W and change in kinetic energy. Here two velocities are given. Inside you can write down given V1, okay, write down as 5 meter per second and V2 as 2 meter per second, right? 2 meter per second and 5 meter per second are given. So change is kinetic energy will be half of mv1 square, that is one kinetic energy, and the change is half of mv2 square, right? What you can take common? Half of m you can take common out, v1 square minus v2 square, right? Now put down the values. What is the mass is given? 20 kgs, right? 20 kilograms, that is a 20 kg. So now put down the all the values. What is the mass is given? 20 into, put down the values, 5 square, 5 1, that is v1 equal to 5 meter per second square, that is a 5 square equal to what? 25 minus, and what is the v2 is given? 2 meter per second, that is 2 square, that is the 2 square means 4, and we know the unit of work done is what? Joule, right? Now cancel out 2, 10, 20, right? So what will be there? 10 into 25 minus 4 equal to what? 21 joule, that is 21 into 10 equal to what? 210 joule. So this is the amount of work we have to do in what? Changing the velocity, okay, of a body which mass is given is as 20 kilogram from 5 meter per second to 2 meter per second. Simple question, simple answer. There's nothing to be get complicated. Simple question, just write down the question, and now we are going to move towards our next question. Okay, this is our next question. What this question is saying, that a mass of 10 kg is at a point A on a table. Okay, consider that this is the point A. Okay, it is moved to a point to B, right? Now it is moved like that to point B, right? If the line joining A and B is horizontal, simply the line joining A and B is the horizontal line, it is in this direction. Now what is the work done on the object by the gravitational force? Okay, explain your answer. Nothing to get explained, I will explain, you just listen to me very carefully. We know if this is a person standing in a ground, okay, we know that gravitational force is acting on every object in the earth, only in the earth, okay? So that force is actually towards the ground. That means what? If there is a existence of a gravitational force, consider that an object, it is here, okay? If the object is here and it is moving in this direction, right? It is moving in this towards the B, it is actually moving, okay? So if there is exists under gravitational force on the object, it will move or it will have a direction like that. That means this is the direction of the gravitational force and this is the direction of the object's motion. Now, what is the thing that you have to actually look after? Is the angle between these two, right? Look very carefully. If the displacement is in this direction, that is towards the B direction, and if I give a name in this direction as C, that is the force having direction in the C direction, now what is the angle between B and C? That is the 90-degree angle. Okay, so now what will be the work done? So to understand the concept of the work done in this case, we have to actually go towards a little bit advanced manner. Now what is the advanced manner? When you will go to the class 11 and 12, you will understand the concept of scalar quantity and vector quantity, right? So we know, again, we have got the concept of the scalar quantity and vector quantity. Work done is a what? Scalar quantity, and it is expressed as force F vector, that is force is vector quantity, you know, dot product displacement. D is for displacement, and displacement is also a vector quantity. So whenever you just have to remove the dot product, it will become F D cos of theta. Okay, that this belongs to trigonometry part. I hope you have to get it, the trigonometry part, right? Now what is the angle between force, that is towards the C, and B, this is the displacement. What is the angle? It is 90-degree. That is F D cos of 90-degree. Okay, so now what we have to check? Value of cos 90-degree. You will know in the future purpose or in the future part that cos 90-degree always have value 0, and something if we multiply with 0, what we get? We get 0. That means work done here will be 0. And this is the reason, because why? The force and the displacement having 90-degree between them. So that is the answer, simple answer. Okay, if you have any further difficulty in understanding that question, just ask me in my comment section. Okay, but this is the answer of this question. Now we are going to move towards our next question. Okay, you just write this down. Okay, and after that just move towards your next question. Okay, now what this question is actually saying, that a certain household has consumed 250 units of energy during a month. Okay, now how much energy is this in joule? That means here energy is given in units. Okay, so we have to convert this energy into what? Joule, right? So how we are going to do that? Just wait for it. Simple question. What is actually given? Energy E equal to how much? 250 units, right? Simply 250 units. So we get that. Now we need this energy in what? Joule form, right? We know that. You should actually know, it is very much important for you that 1 unit of energy, okay, is equal to how much? Do you know that? 3000 it has value 3600 again 000. This is in joule. This is only value for 1 unit of energy. And how much energy is there in case of a 1 unit of energy? Now, how much energy we have to calculate? It is 250 units of energy, right? So 250 unit of energy is equal to 250 into 36. How much zeros are there? 5. 2, 3, 4, and 5. Okay, it will be in joule. So if you multiply 25 into 36, you are going to get 900. Okay, now how much zeros are there? 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6 joule. Okay, whenever you use greater quantity like that, you always actually replace that quantity to in power form. That is 9 into how much zeros are there? 1, 2, 3, 4, 5, 6, 7, 8. 10 zeros are there. Sorry, 8 zeros are there. So how can you can write 9 to 10 to the power 8 joule? So that is 250 unit of energy. Okay, is equal to how much? 9 to the power 8 joule. Simple question. Always remember that energy. If the energy is given in unit form, if you have to convert it to joule form, you always remember that 1 unit of energy is always equal to what? 3,600,000 joule. Okay, it is in the what? A British form actually. How if our actually units, it is the nothing but what 36 lakhs of joule, right? So yeah, it is the 3 million. Okay, so if you always remember that 1 unit of energy is equal to this much of joule. Now if any 300 units of energy, if you need just multiply with 300 with this 3 lakhs or 600,000, and then you are going to get the unit of energy as 900 and or something, whatever you need, you are going to get that. Simple question, right? That's always what you have to remember. This one, this thing you should always remember. Okay, you may get question in your term 1 exam that if the energy is given in unit form, how you are going to convert to joule. If any kind of amount of energies are actually given, just multiply with actually this that value, then you are going to get it in joule form. Okay, simple question. Now we are going to move towards our next question. Okay, this is our next question. What this question is actually saying, an object of mass, that is mass is given, write down the mass, m is equal to how much given, 40 kilogram, right, is raised to a height of 5 meter above the ground. Again, height is actually given. How much height is given? 5 meter. Now what will be the potential energy? We need the potential energy. We don't know the potential energy. Okay, if the object is allowed to fall, find its kinetic energy when it is halfway down. Okay, so that means what is the condition is actually given here. Okay, consider this is a ground. Okay, and the object rises to a certain height. Okay, this is the certain height, that is the A position, and how much this height is? 5 meter, and object is here. What is the mass? The given 40 kg. So mass is given, m is given, height is given. We know the value of g. We will consider the value of g as 9.8 meter per second square. This is the standard value, right? So we will consider the g equal to 9.8 meter per second square. Now first we have to calculate the potential energy. We will just first consider that. Okay, what will the potential energy? Pe, that means the potential energy equal to, what is the formula? mgh. Now what is the value of m is given? 40, and what is the value of g? 9.8, and what is the height is actually given? 5. So the unit is kg meter square per second square, right? So if you solve this, you are going to get 98 into 20. Okay, I just actually simplified, and this kg meter per square per second square known as what? Joule. So if you solve this, we are going to get 1960 joule. So that is the energy, that is the known as potential energy. Now what we know from the concept of the conservation of energy is that the total energy of the system remains constant, right? Here, if the potential energy is the maximum energy, it is the maximum height. Okay, so here what is, if the body is at rest, okay, that means the kinetic energy will be how much? 0. Okay, kinetic energy is 0. So the total energy will be how much? Total energy will be how much? Potential energy plus kinetic energy equal to, since kinetic energy is 0, it will be 1960 joule. Okay, again, if the object is here, right, so the kinetic energy will have the maximum value of the velocity and the height will be 0, then what will be there? Then the kinetic energy, potential energy plus kinetic energy, again the potential energy will be 0 at this position. This is the position where the potential energy will be 0 because height is going to be 0, and the kinetic energy will be maximum. That value will be 1960 joule. So now what we have understood from these two cases is that the total energy of the system remains constant. Okay, so now the question is, if the object is allowed to fall, find its kinetic energy when it is halfway down. That means when the object is here, that is almost half. Okay, that means this height is almost 2.5 meter. Okay, that is the whole distance is 5 meter, the half at the, it will be 2.5 meter. So now we have to calculate the kinetic energy at the half. Okay, since it is halfway down, the potential energy will be half as it is because the height becomes half, right? If the potential energy becomes half, the next half energy will be how much? Kinetic energy, because we know that if the half is the potential energy and the total energy have to be what? 1960, right? If you divide this potential energy by 2, you are going to get the potential energy as half. That means the half value of the potential energy will be equal to what? Kinetic energy. So what you can say, the kinetic energy of the body when it is halfway down is equal to half of, right, potential energy we can write, right? It is half of 1960 joule. The energy will be how much? 980 joule. So that is the answer of the question, right? If you see, if you need the confirmation of this answer, if the potential energy becomes half, that is the this much, you are going to get the 980, that is the 980 joule. So the rest, the kinetic energy have to be 980 joule, because why? If you add 980 plus 980, you are going to get equal to 1960 joule. So what you have understand, that the total energy of the system remains constant. That is the base of the solution, okay, or what you can say, this is the base on which we can actually solve this question. So this is the answer of the question, right? So we are now going to move towards our next question. You just write down this question. After that, we are going to move towards our next question. Okay, now this is the question where power is given. Power P equal to 1500 watt, right? And now what is extra thing is given? The time T equal to how much given? 10 hours. Okay, so we have to calculate the energy, right? So for that, we write down the formula. We know that, what do we know? We know that P equal to E by T. Simple formula. From here, we can calculate the energy. E equal to P into T. So what is the P is given? 1500 watt. And time is given 10 hours. So what we are going to do, we are going to convert the hour into seconds, right? So in 1 hour it is the what? 3600 seconds. So in 10 hours it will be obviously 36000 second, right? So 1500, so 1500 into 36000 watt second. So if you solve this 1500 and 36,000, you are going to get almost how much? Just solve it. Okay, 15 into 6 equal to 90. 9 is remainder. 15 into 3, 45. 45 plus 9, 54. Okay, 540. And how much zeros are there? 2 plus 3, 5. That means 2, 3, 4, 5. And this watt second is also known as what? Joule. I will write down in some standard form. It will be like 5.4 into 10 to the power 7 joule. So that is the answer of this question in joule format. Okay, if you just keep it here, it will also be not wrong. Okay, but always try to keep the answer in standard form, that is the 5.4 to the power 7 joule. Okay, it always becomes some actually conventional method to keep the answer like that. Never keep like the answer 554 and after that I am putting 6 zeros. It is not a standard form to keep the answer, right? This is the standard form where you should keep the answers like that. Okay, you should always remember that, because once you move towards the higher classes, that is the class 11, 12, if you keep the answers like that, it will not make some good sense of that. Okay, so always keep the answers like that. This is the standard form. Okay, so simply write down this question, and quite simple question. Now we are going to move towards our next question. Okay, this is our next question, right? What this question is actually saying, that this kind of conceptual question. It is not going to be a high mark question. It is almost 1 mark question. Okay, because if the questions are given in the optional form, it will only give the options. So you have to solve this question in very short period of time, right? So what is the questions are given actually? So an object of mass m, okay, mass is given as how much? M, right? Is moving with a constant velocity. Velocity is given how much? V, right? So now we have to find out the work done, okay, in order to bring the object to rest. Okay, so consider, we will write down something. Okay, let me do one thing. I will just remove this velocity part. I will write a little bit differently, okay, for your convenience. Okay, how I will write? I will write here initial velocity. I will write down like that, initial velocity. Okay, I will consider initial velocity as v because it has started from b. You can consider that, and final velocity. Okay, What will be the final velocity? Can anyone tell me that? See what is written here. The object have to be raised. That means the final velocity will become how much? 0. Right now? And here mass is given. We know the work done. We know the work done. That is W is equal to how much? Change in kinetic energy. Right now? So what will be the change in kinetic energy? Half of mv square minus the second velocity is 0. So the kinetic energy obviously will become 0. So now what will be the answer? Work done will be half of mv square. So what you can write? The total work done, okay, in bringing the object to rest, in bringing the object to rest, okay, will be how much? Half of mv square. Simple question, simple answer. These are not that much high mark question, okay. If that type of question comes, it will only carry 2 marks, okay. And if there are additional one more question, that is 2 plus 2 4 marks, okay. So don't worry about that. Quite simple question. Just write down this question and we are not going to move towards our next question, okay. Okay, this is our next question. What this question is actually saying that calculate the work required to be done to stop a car of 1500 kg moving at the velocity of 60 km/h. Similar conditions are actually given here. Now the quantities are a bit different. Similar type of answer, okay. We'll solve it, okay. So how we are going to solve that? First, what is the mass is given? 1500 kg. Now we are considering the first velocity. It is a v1 as 60 km/h. You now just convert it to meter per second. 60 into 1000 by 3600 meter per second. If you solve this, you are going to get 50 by 3 meter per second. Right? You get that? Now, what is required here? What is given here? The work have to be done to stop the car. That means we have did some work. Now the car will be at rest. So the velocity v2 will be how much? 0. So now the work done, similar formula, the work done equal to half of mv1 square minus half of mv2 square. Right? So write down half of, what is the m is given? Constant thing, 1500. Now what is the second velocity? The first velocity is given 50 by 3 whole square, right? 50 by 3 whole square. Now the fact is, what is actually given here, right? Second condition is given as v2 equal to 0. If the v2 is 0, that term will be what? 0, right? So if you do some further simplification, it will be only 1500 by 5 into 5, 25, double 0, 3 into 3, 9, right? So we can solve it, okay. We can actually cut it down like that. 2, 7, 14, 2, 5, 0, right? If you further solve this, you are going to get 750 into 2500 by 9, and the work done will be in Joule format, okay. So you just try to solve this by yourself too, okay. So I think that answer is going to be almost how much? 208,333.3 Joule, okay. That should be the answer actually, okay. You just try to solve it by yourself. If you get any kind of different type of answers in there, just inform me in my comment section, okay. That's how answer should be a little bit different. So answer is this one, 208,333.3 Joule, okay. So that is the amount of work done that have to be done, okay, in stopping a car of mass 1500 kg which was moving at a velocity of 60 km/h, right? So that is the answer of this question. Now we are going to move towards our next question, okay. Okay, this is our next question. What this question is actually saying, we have to solve it, okay. Once we solve it, you are going to understand that. Find the energy in kilowatt hour consumed in 10 hours by 4 devices of power 500 watt each. That means there are 4 devices actually given, okay, of which the powers are actually in the rate of 500 watt each, right? So write down the power P equal to 500 of watt each. Okay, that means each device carrying a power 500 of watt. Now what is the time is given? 10 hour. So now we're going to keep the time in hour because we have to find out the energy in kilowatt hour format. So we don't need to convert this hour to second. We just have to remember that. We know the formula of power P equal to how much? E by T. So from here what we can write? E is equal to P into T. Okay, that lizard is making sound tick 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 tick. That means I am saying true. Right? In our SMS culture, it is mentioned that if the lizard is making sound like tick 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 tick, it always actually what provides the information that I am saying the truth. Okay, yeah, these are some beliefs in our SMS culture, so we have to move according to that, right? Okay, so yeah, this is something that we should actually hearing that. Then actually from scientific way, these are not the things. They are actually maybe that lizard is actually connecting with other lizard, right? Maybe he is just calling his friend, tick tick tick. That means come here. I'm just waiting for you, like that, right? So that is the fact. So don't go for that sounds. They will make their sounds. Now we are just making our own sound, right? That means my voice is the sound for you, right? And by the term sound, I'm actually getting in mind that our next lesson is going to be what? Sound. This is one of the interesting lessons. It doesn't matter that lesson needs for your final exam or not. We will cover that lesson because do you know why? Because once you're just going to move towards our higher secondary, that is the class 11 and 12, that lesson is going to be very much important one. Okay? Because the questions from that lesson, that is known as what? Sound, is going to come in your entrance exam. Okay? If you just after completion of your class 10, if you have to give some entrance to take admission in some higher school, that is from 11 and 12, the questions will definitely come from the sound part. Okay, it doesn't matter if the Cbse is not including that lesson sound in your syllabus. We will cover that. We will solve that lessons, every problem like now we are solving it. So when I was just going to upload the videos of the lesson, do watch the videos. Okay, those students who are actually interested in physics and want to learn something new, they will obviously watch that. So I am actually hoping that you are going to watch the videos and we will make proper video on that because we have to cover all the physics syllabus. It doesn't matter what the syllabus, the Cbse is actually given. We will prepare for everything. Okay, we'll skip nothing. Okay, skipping something is almost bad. Okay, so now just solve this question. What is the power is given here? 500 watt. And what is the time is given? 10 hour. If you just further solve it, what you are going to get? 5000 watt. You don't need to give the cross sign. Watt hour. We know that 1 kilowatt equal to how much watt? 1000 watt, right? So that 5000 watt will be how much? 5 kilowatt hour. But this is for only one device. But we know there are 4 devices are given. So how much energy will be given for 4 device? Energy E will be 5 into 4 kilowatt hour. That means 20 kilowatt hour. Okay, that is the answer. But if the question comes and if they tell you that also find the answer in units, okay, then we get that what? 1 unit of energy is how much? 3600, like that, this type of energy in joule, right? We actually converted that. Okay, now if they asked you that if just for actually convert this energy in what unit form, so if simply do one thing, 20 unit. Okay, because we know why, because 1 unit is also have a term that is 1 kilowatt hour. Okay, you just always keep it in mind. Okay, 1 unit of energy is equal to 1 kilowatt hour. Okay, that is the 20 unit. So that is the answer of our question, and that this was our last question from the exercise part. Okay, those questions who have still left, if you have had a doubt, those are quite simple questions. Try it by yourself. Okay, if you are not able to solve these questions and if there is any kind of difficulty in the other question that is actually given in the what in the exercise part, just ask me frankly in my comment section. I will solve it for you. Okay, so these are all the problems that we have to solve. You just write it down in your copies properly. If you have any further doubts are there, just ask me openly. Okay, I am always there. I have to help you. Okay, so this is the end of our classes, and we'll meet you in the next video, which will be on the base of the lesson, that is nothing but what? Sound. By the way, when all the lessons are going to complete, we will do one revision, okay, for each lesson. Okay, and after that we will solve some extra problems outside of this NCERT book. All right, because if you just only solve the problems that is actually given in the NCERT book, and if you're just thinking that okay, now we will be able to solve all the problems, no, we have to do lots of actually numerical problem. We have to practice more, so that we don't know what type of questions are going to come in the board exam. So we have to prepare for the everything. Okay, so be positive, keep motivated. Okay, so we will now end this class here. Again, we are going to meet in the next video. So till then, bye bye everyone. So stay blessed, stay happy, and keep safe. Bye bye.